Okay, so chapter 2 or even section 2.1 goes on for a really long time, so it's not going to be like one video for all of chapter 2. These things right here, these are frequency tables. Okay, so if I'm like doing magazines, this comes off the notes page for chapter 2. I'm doing a little bit out of order because I'm trying to guide more by like the homework, so I'm like down here on example number 4. Examples number 1 through 3, it would be just creating your own frequency table to go with all those numbers. And I'm not really sure, there might be a homework problem on that, but we'll see when we get to it. All right, anyway, but the first few homework problems are like this. You get a frequency table. Now what this is maybe I'm studying magazines and I want to know, okay, well, how many magazines you get delivered to your house per month? And I go around and apparently I've asked 14 people and they tell me, but I class them into little categories. The people who said 0 to 2, well, there was 8 of them, okay, and they're all fitting in that category right there. And then the ones who said 3 to 5, 6 to 8, and 9 through 11. Those are the groups that I had. Now, these little groups are supposed to all be the same size as each other. Okay, so class width is the beginning of one to the beginning of the next one. Okay, so the width on this particular chart, all right, so from 0 to 3, 3 to 6, 6 to 9, in each one of these classes, you could be one of 3 things. You could be 0, 1, or 2. You could be 3, 4, or 5. So it's a distance of 3. Okay, I don't want to call it a distance of 2. All right, if I'm subtracting here, that would be 2. But I want to go all the way from the beginning of one to the beginning of the next because there's 3 different things in there. Okay, so at the beginning of one to the beginning of the next, I could just go, okay, well, 3 and 0. All right, 3 minus 0, that's 3. So that class width would be 3. And it has to be consistent. You see this all the time when you're reading about a survey somewhere, is they'll go, oh, and 9 and up. They're not supposed to say that, okay? They're supposed to keep all of their widths the same. So if they're thinking somebody else is going to answer with 23, they're going to have categories all the way until they get down to 23. The widths are always supposed to be exactly the same size as each other. If I have to do the widths down here, 0 to 2, 2 to 4, 4 to 6, 6 to 8. Okay, so the width on this one is 2 minus 0 equals 2. That distance in there. You don't have to use the first 2. I could have said, oh, 6 minus 4. That's 2. Just as long as you go from the beginning of one to the beginning of the next. And you don't have to answer it 5 times. You just answer it once. The width for this table is 3. The width for this table is 2. All right, now that's class width. Class midpoints. Now I'm going to need actually to do a midpoint for each and every class. Okay, so 0 to 2 is going to have its own midpoint. 3 to 5 is going to have a different midpoint. And what they are is the middle of this. Now I could probably look and tell you what the middle of 0 and 2 is. It's 1. But the way you would do that is you would go first plus last divide by 2. Okay, and that would give me, well, 0 plus 2 is 2 divided by 2. That's 1. Okay, that would definitely be the midpoint there. I could have done that one in my head, but basically what it is averaging these two. So 3 plus 5, that's 8, divided by 2, that's 4. So the width there is 4. 6 plus 8, that's 14, divided by 2, that's 7. I could have done these in my head. All right, and 9 plus 11, that's 20, divided by 2, that's 10. And something you can notice about the widths is they're always, this is not the widths, this is the midpoints. Something you notice about the midpoints is that they're always a width apart from each other. Okay, is that the width was 3, and that's 1, that's 3 later, 3 later, 3 later. They're always, if you didn't want to do the calculation a bunch of times, you could have just kept going up, plus another 3, plus another 3, plus another 3, and that would have given them to you. All right, so now let's try the midpoints down here. Probably going to need a calculator, because if I do the first plus the last, 0 plus 1.99, that's 1.99. And then I got to divide that by 2. So 1.99 divided by 2.995. Now that's why I needed an actual formula, because it's really hard for me to see what's supposed to go in there. Okay. And then I'm too lazy to do the calculation over and over. The width here was 2, so I'm just going to keep going up by 2. 2.995, 4.995, 6.995, 8.995. And those are the midpoints for that. Okay. This couldn't go 0 to 2, 2 to 4, because if it did, then all the people who were at 2 would be like, I don't know which one to pick. So you can't actually, you're not supposed to overlap. Again, you see that done all the time. You're not supposed to overlap those. That's why that was 1.99 to start with, and that's why it screwed up our midpoint calculations. All right, now boundaries. Okay, boundaries. It seems like, why do I even care? If I was drawing a histogram, and I'm making these little bar charts right here, there's 0 right there and 2 right there, and I go to draw the next one, that'd be 3 and that'd be 5. That's actually a bar chart. A histogram, they want to make you make all of your bars like extra fat so they touch each other. And so this point right here isn't actually 2 or 3. It's in between the two of them, and that's how fat the bar would have to be, so that they were all bunched up against each other. So it's a way of deciding, if I was for some reason going to freehand a bar chart, it's deciding where that actually goes. Okay, so it's not, you know, a calculation you see done all the time. You probably just freehand it anyway. So, but the boundary is the spot that's halfway between this 2 and that 3. Okay, well, if I have to make a spot that's halfway between 2 and 3, well, okay, again, I'll just 2 plus 3 divided by 2, that's 5 divided by 2. So 2.5. All right, and then the one that's halfway between 5 and 6, 5 plus 6 divided by 2, 11 divided by 2, so that's 5.5. Oh, wait a minute, maybe I could just get away with that whole trick of just adding widths on every time. Okay, once I got the 2.5, why didn't the width here is 3, why don't I just keep adding that on? So this would be 8.5, and this is 11.5. 11.5, that's not even in the list. Well, that's because I kind of had to fluff it out. After I do 8 to 9, this last bar has to be poofed out to the exact same 3 as that. Okay, so even though there's nothing out there, I don't even have 11 to calculate to the next thing, I just know it fits the pattern. Okay, well, that means I need to know the boundary on the other side. If they all have to be fluffed out, then this, something up here before 0, has to be, I have to fluff it out on both sides, so I got to go backwards by 3. Okay, so this negative 0.5 and this 11.5, they're just sort of tack-ons. All right, all I did to get that negative 0.5 was I went 2.5 minus 3, because that's this boundary right here, and then minus the width. Okay, so I now know where I'd put all those markers to make the beginnings and endings of my histogram. We're going to do histograms, but we're going to freehand it, and I probably won't be all too accurate or put these boundaries on at all, but that's the theory behind them and what they're doing there. Okay, is that they're the spots where the two bars of the histogram smoosh up against each other. All right, so I need boundaries down here. The point halfway between 1.99 and 2. Oh, yeah, I better do calculation on that one. 1.99 plus 2 divided by 2. So that's like 3.99 divided by 2, and that's 1.995. Yes, 1.995 is, in fact, in between 1.99 and 2, so that's a good sign. It's not the same as the midpoints. That was 0.995. There wasn't one. I didn't say 1.995 for that. So, and I'm definitely never doing that calculation again. So I want to keep going up by 2. So 3.995, 5.995, 7.995, 9.995. Oh, that's the end. That's the tack on that side because there isn't really one right there. And go backwards from here, it'll be negative 0.005.